Today we're going to look at two items. Number one, we're going to talk a little bit about motion and constraints dealing with motion. So we're going to have this rod actually pivot based on the motion of our rocker arm here. The second item that we're going to talk about is Inventor Studio. And so Inventor Studio is the rendering and animation component of showing how to animate objects as they are currently assembled using constraints that you've placed on the objects. And so we'll deal a little bit about Inventor Studio, applying materials, and a few other things in that vein also. So the first thing we have to do is get this rod set up so it actually tracks with the pivot arm here, with our rocker arm. So the first thing we're going to do is under the Assemble tab we're going to go ahead and constrain the center of the cylinder to the center of the guide hole. And the second constraint we're going to apply, I'm going to go ahead and cancel this, move the rod back out so you can see the rod itself. The second constraint that we're going to apply is going to be a mate constraint. And so we're going to mate this rod to the top surface. So we're going to constrain it using the mate tool. We'll pick the top surface, but instead of picking the bottom surface of the rod, because, well, let's show you what happens. If we pick the bottom surface of the rod, everything constrains properly, right? But we can't move it. We can't move it because the two surfaces are now constrained firmly with each other. And that doesn't allow my rocker to pivot. So I need to locate a constraint that allows me to pivot on this object. Well, if I were to pivot on this object, I'd want to use the edge of the rod and not the flat surface of the bottom of the rod to make that constraint. So we can edit the existing constraint or we can create a new one. So I'm going to go ahead and delete the constraint and we'll just create a new constraint. I'm going to move the rod back out again and constrain the surface. But this time, instead of picking the face of the bottom of the rod, I'm going to pick just the outer edge. Okay, so now the outer edge of the rod is applied. And so if I pull the rod, you can see how it tracks with the item. And yes, if I pull it far enough, it will continue to track with the item. But we can set some constraints to limit the motion of this rocker arm, because the rocker arm itself can only move as low as the surface. Now, realistically, I can still pull it right now, but that isn't real. But right now, it's basically only to be able to be moved to the edge of the surface. And you can see that the edge of that surface isn't 100% based on the angle, but it's fairly realistic. It gives us a pretty realistic motion of the movement. So how do I control the rocker arm? Well, I can put an angle constraint on, and the angle constraint is also the constraint that we use to control the motion. So I'll put the angle constraint on. So we'll constrain using an angle the base surface and the bottom surface of the rocker. And let's see here. This one may fail. And let's see here. We're going to do 180. And the only reason why we did 180 is because if I did 0, I think it would flip it over. If I do 90, yeah, it's going to fail. And it can't resolve it. So let me edit the constraint. And so let's go ahead and do 180 and apply it. So what we've just done here is we've made a constraint, this angled constraint here, that allows us to motion or show the movement of our object. And that's called a drive constraint. And so the drive constraint allows us to move, in this case it's going to go from 180 to 190, and we can see that it motions just a little bit. But how far do we actually need to make it move? Well, let's look at that front view again, and instead of 190, let's set it up for 200. 200's a little bit too much. Why? Because we had a collision. Now, could I set up collision detection? You bet. So let's reverse it. Collision is detected, but I think it's going to be with that. Yeah. So the collision's detected between these two. So I can't set up collision detection on this movement, but I bet you if I set it to like 198, we'd be good on this side. Yeah, 199. Perfect. Now on the other side, I could probably go below 180, so we can go 160. Whoops, let's type it properly. And so 160 is about where the bottom of this goes to about 199. So we've got about a 39-degree motion that we can work with. Now we can control the amount of steps and the repetition. So if we want it to start, end, start, move up and down, we can actually drive it and say, okay, I want 2 repetitions. So it goes start, end, back to start. And we can control the number of steps. And there's 39 steps, or 1 per degree. And so if you wanted it to be more accurate, you could double the amount of steps. You can make it a half a degree, and so forth. So it's a start, end. Let's do a start, end, start. Start, end, start. So if we do a start, end, 2 repetitions, it's just going to redo the same thing. If we do start, end, start, it looks much more realistic of it moving up and down. If we do 3 repetitions, same thing will happen. Start, end, start. Okay, so you get the idea of how we can control the motion now with a simple angle constraint, and when we right mouse click on the angle constraint, we get the drive constraint option. So now we've set up our motion. Now it's time to look at how we can animate it. So let's move over to the Environments tab and Inventor Studio. Now Inventor Studio can be a whole class upon itself. The capabilities of Inventor Studio is much like an art department. You've got total control of everything. Lighting, color, materials, camera location, camera movement, editing capabilities to cut from camera 1 to camera 2. Lots of different capabilities. If you're familiar with the product called 3D Studio Max, Inventor Studio basically is a smaller version of 3D Studio Max. Many of the same things that were involved in Studio Max are involved here. Okay, so how do we get started? Where do we get rolling? So the first thing we're going to do is put down an animation timeline. This will give us an idea of how long of a video we're going to create and starting and stopping points of key features. When we do this, it says that the animation commands are not active in the model state. Let's go ahead and activate them. And here we go. So we've got an animation timeline. And the animation timeline goes basically from 0 to 30 seconds. Well, if you think about 30 seconds, that's a pretty fast animation. That's a typical commercial on TV today. And within that 30 seconds, you're going to be generating 900 frames of animation. Animation runs at about 30 frames per second. And so you'll generate nearly 900 of these frames. What this also will allow us to do is expand the action editor. So when we put different steps in, We're going to see the different animation steps that we're going to work with, and then we can also do other animation options as part of this time frame. So a couple of other things that we're probably going to set up here that I'd like to set up is a camera, because we're going to move the camera, and then we're also going to animate our movement with the drive constraint. So let's go ahead and create a camera from our view. So we're going to create a camera here. So this is going to be camera 1. So just in our current view, that's camera 1. And if we take a look around, we can see that camera 1 is actually out in space. It gives us a camera and a target. Can I manipulate these? Yes. Camera 1, I can grab and move it farther away. I can actually look through it. So if I right mouse click on camera 1, I can edit it, move it, delete it, but I can also view it. So I can set view to the camera. So that's my camera view. So I'm looking at the target or through the camera. We're going to create a second camera, which we are going to move, and maybe we'll create a camera on the second one. And I like doing this in the sense of creating the cameras based on the views. It makes it easy to create cameras that way, and so we're going to create a camera in this direction also. So let's go ahead and generate a camera. We'll choose OK on our pan, right mouse click, create camera from view. Bingo. So we got camera 1 and camera 2. And what that is going to allow us to do is on the timeline switch from camera 1 to camera 2 when we begin our animation. Lighting, I'm going to go with standard lighting. Now you can get into a lot of different lights, and as the minute you start creating lights, you delete the ambient light or the global light that you currently are working with. But if we were to create a light, we could do general illumination, we can turn shadows on and off. We can also do point lights, meaning spotlights. And so if you wanted to put a light inside of a desk lamp, you can control that. You could then highlight and shadow objects that are on a desk. Remember, this is a full rendering package. So shadows, point lights, ambient lighting in the room, all part of the capability of what we can do. I'm not going to add any custom lights in our design. However, one of the nice features that we work with is the ability to fade objects. And so we can control objects and fade them in and out. So if I wanted to fade out the bracket or fade out the original holder so I can see the actual motion, I can do that. So we're going to definitely fade out an object during the animation also. We can either animate components or animate constraints. I've found that animating components is more difficult. It works, but it's difficult. That means at a set time in the animation timeline, you're going to move a component to a position. The computer will then interpolate that movement and move that object linearly from point A to point B. When we deal with constraints or animation of constraints, you've predetermined how the object moves, like we did before with that drive constraint. That's what we're going to use to animate our constraints. Again, this gives you a much higher level of control and accuracy in your animation. So let's go ahead and animate a constraint. So we're going to pick a constraint, and a lot of times you can just go to the browser bar and do the same thing. So on the handle, we want to animate this constraint. So that constraint will be animated. Notice that it starts at 199 and goes to 199. I actually want to go from 169 to 199 over a set period of time. And so there's two ways that we can edit this. So I'm going to work with constraint, the start and the end. So we're going to go from 199 to 169. And the timeline is going to go from 0, and I can put a duration in here, and we'll say 15 seconds. Okay, so it's going to start at 0, end at 15, and we're going to have an animation motion. Okay, so in 15 seconds, we can animate the movement. That's one motion. Let's go ahead and re-rack it. Got to remember those VCR and CD DVD buttons. And let's go ahead and play that motion. You can see how slow it is there. 15 seconds though. That is pretty darn slow for movement. But that may be the way that it moves. But what if it isn't? What if we actually need to speed this animation up? Because right now I'm only in 14. Boom. Alright. So what if we wanted to speed this up? Well, I could constrain this and move it back and say, alright, we're going to do the same animation, but in 10 seconds. That's the advantage of using the timeline. So I can replay it again. This time the movement's going to speed up significantly. And if I make it another movement difference, so we'll do 7 seconds, and so it moves really nicely in 7 seconds. Okay. So now I've got a 7-second animation that I just did. But don't I want this to continue? Well, I can edit it. So I can right mouse click on the animation, choose edit, and it brings up our edit window again. Other things that I can control. Just doing a quick control here. So it's going to move it, right now it sets it in 2 seconds, but actually I wanted about 7 seconds total. But I can control acceleration. And so, again, realism, if this thing has a specific acceleration that it must meet, I can work with that. So it's going to use 20% of its time to accelerate to full speed, 60% of the time is going to be at full speed, and then 20% of the time is to slow it down. If I want to go constant speed where it just has absolutely no acceleration associated with it, then it won't look as realistic. I wonder if I can copy these. So that's in 7 seconds. I can copy the action. Or, even better, I can mirror it. So it goes... Well, what did that just do? That just automatically added on another 7 seconds. Let's re-rack it back to 0. Let's watch 14 seconds of video. So here it is. In 7 seconds it goes up. 4, 5, 6, 7. And now it mirrored it and it goes back down. How very sweet. So what that means is that I can again mirror it, and now we've got 21 seconds of animation video. So it's going to go down, up, down, and we'll mirror it once more. So we'll get in 30 seconds 4 movements. Okay. Really easy to do. We can also, as part of this animation, I mentioned that I can move cameras or switch cameras. So I can create camera views in here. We're going to go ahead and animate camera 2. And so I'll choose, right mouse click on camera 2. We'll choose animate camera. And so what we're going to do is not physically move the camera, but we're going to switch to it under a specified time frame. So we're going to specify that camera 2 is going to be 15 seconds Duration will be 8 seconds of view. So the end is going to be 23. So it'll go from 15 to 23. No movement per se. It's just that it's going to switch from those cameras. Okay, so we'll choose OK. And so now, again, it adds a new path for me, 15 to 23. Just did 23 seconds. Uh-oh, what can I do? We're OK, because it goes to 30, 15 to 23. So let's go ahead and set our... We're at about the 13th, and play animation. And so what we can do is stop camera 1. We'll animate camera 1 from 0 to 15. Define the camera. Basically, it's going to be floating in its current target and placement. We're not going to change it. And so from camera 1 will be 0 to 15, and then we'll also be camera 1 again. We'll animate camera 1. But this time, what we can do is we can zoom this camera. So we're going to start at 23. Let's specify. Start at 23 and go to 30. And we could put it on a turntable, and we can do a half a revolution in a minute. And so it'll kind of put it on itself on a turntable here. And so it'll kind of turn itself around. So when we actually render this, we'll have a finished rendering of this object. And we can watch this particular animation. What about materials? I can pick objects and apply materials. No different than inside the actual software itself. The material I put will then have a much crisper finish on it, and so that works really, really well for the animating purposes. Now, for us to actually do this, what we do is record the animation or render the animation would be the actual way to do this. If you're doing a test, my suggestion is stick with the 640 by 480. If you're going to post this, you may change different outputs. And this is for a quick render. If we were to output this, we could actually output it, time range, control the anti-aliasing. And the anti-aliasing is the, see the little jagged edges? We can control that. The higher the anti-aliasing, the larger the image is. And we can output the format into an actual video itself as opposed to individual slides and work from there. To do that, we'd pick the file and then give it a name and the whole deal. If you put reflective materials, it will also render the reflection realistically in that material. Really cool, but really big on file size. Alright, let's run a render. And we'll save the video. And it's going to be a custom. And what you're going to see is right now we're just rendering this current image, and there's 450 images. And so I'm just rendering my current view. Alright, so I'm going to stop the render, the video producer. Yes, we set up our camera movements, but we did not set up the video producer for the camera shots. So what I need to do is take our video producer and let's go ahead and delete that one. And what I've done here is I've dragged and dropped camera 1 in, camera 2 in, and so forth. And so what we're going to do is delete out the extra one that I dropped in. So camera 2's in the middle, camera 3 goes for 30 seconds. We'll then re-render this video using the video producer, and we will get our output. And again, we can render this as at a higher resolution if necessary. What I'll do is I'll attach the final rendered output to the end of our video so you can see exactly how the different cameras are produced. Have a great day.